In this chapter, we learn the concepts of arithmetic progression, a common difference. We learn how to find the nth term of an arithmetic progression, the sum of terms of an arithmetic progression. We learn about the average of an arithmetic progression, and we learn how we can use the average of an arithmetic progression to find the sum of an arithmetic progression. We look at the average of an arithmetic progression having odd number of terms, average of a progression having an even number of terms, and so on. We learn the technique of visualizing an arithmetic progression. This is a very good and an extremely useful technique when we deal with progressions. It could be arithmetic progression, geometric progression, or in general series and sequences. This visualization will help us, one, to understand what's happening in the problem, and two, it will also help us to actually work through the problems much faster than using the formulae that we have learned. We'll learn about arithmetic mean, how we insert arithmetic means between numbers. We'll also learn another technique of dealing with problems in arithmetic progression, geometric progression, sequences and series, in all those topics, which is about assuming values. You can actually assume values, and this technique can be used in solving a lot of problems which come in these topics. So let's visualize this arithmetic progression. What we did was we used the formula of Tn is equal to a plus n minus 1 into d. We got two equations, we solved, we found a, we found d, and then we found S10. Now let's visualize this progression, see what's happening, and do the same problem. We know that the fourth term is 15 and the ninth term of this progression is 35. Let's look at what happens here. You add a d here, you get the fifth term, and to the fifth term you add a d, you get the sixth term. To the sixth term you add another d, then another d, then another d. So in effect we are adding d plus d plus d plus d. Right? To move from the fourth term to the ninth term, we are adding 5d. So 5d must be equal to 35 minus 15, which is equal to 20. So our d is equal to 4. So now we have found our common difference d. So once we know d, we can find out t1, and then we can use the formula which says Sn is equal to n by 2 into 2a plus n minus 1 and all that. Now let's take an alternative approach, which is that the sum is equal to average of the AP into number of terms, which is 10. So what would be the average of this AP? It would be the average of the first term and the last term, or the average of the second term and the n minus 1th term, or the second term from the start and the second term from the end, or the third term from the start and the third term from the end. So you can take any of these. Let's take the first term and the last term. So what would be our first term? It's very easy. We have 15 here. D is our common difference. So this is going to be 11. This is going to be 7. This is going to be 3. So easy. This is 35. So this is going to be plus 4, 39. So what will be the average of 39 and 3? 39 plus 3, 42 by 2, which is equal to 21. So what would be the sum? 21 into 10, which gives us 210. So visualizing a progression like this literally makes things extremely easy for us. If you're actually used to doing it, we don't even have to do anything. And you can do this visualization in your mind also. right? So once you find your D, you know what your first term is, you know what your last term is. Everything can happen in our mind. So make note of this technique of visualizing your progression. It could be an arithmetic progression, it could be a geometric progression. You can also use this when we deal with specific problems in sequences and series.